This video covers section 6.1, Rational Functions and Multiplying and Dividing Rational Expressions for Math 95. Our goals in this section are to find the domain of rational expressions, simplify rational expressions, multiply and divide rational expressions. Before we start looking at rational expressions and functions, we're going to go back and look at rational numbers. You know what these are. These are just fractions. Rational numbers have an integer in the numerator and in the denominator. For example, something like 1 over 3, or 7 over 2, or 10 over 12. Each of those are rational numbers. Some rational numbers can be simplified by canceling common factors. For example, when I wrote down 10 over 12, you might have noticed that 10 and 12 each have a 2 in common. 10 divided by 2 is 5, and 12 divided by 2 is 6. This guy's now simplified because the 5 and the 6 don't have any factors. To look at that another way, we could have had our 10 over 12 and then rewritten each of these numbers as a product of 2 and something else. 10 is the same as 2 times 5, and 12 is the same as 2 times 6. Now I see that I have a 2 in the numerator and the denominator. I can cancel that out, and it leaves me with 5/6. So we can simplify rational numbers. We can also multiply and divide them. For instance, if I have 1/3 multiplied by 7/2, I multiply those fractions straight across. 1 times 7 is 7, and 3 times 2 is 6. And there's my final answer for that multiplication. To do fraction division, remember that you flip and then multiply. For instance, if I had 1/4 divided by 3/5, I would rewrite that as 1/4 multiplied by 5 over 3, flipping the second fraction and then multiplying. And now I do exactly what I did before. I multiply straight across. 1 multiplied by 5 is 5, and 4 multiplied by 3 is 4. We can also add and subtract fractions. For instance, if I have 2/3 plus 1/2, I can add these together. The first thing I need to do, though, is make these into the same kind of thing. I need to make them both have the same denominator. To do that, I'm basically going to unsimplify these fractions, adding factors to the top and bottom until the denominators are the same. I notice that both 3 and 2 will go into 6, so I'm going to build up my fractions until they have a 6 in the denominator. In order to build up 3 into 6, I need to multiply it by 2, which means I must do the same thing to the top of the fraction. Remember, I'm unsimplifying this fraction, so I need to add the same factor to top and bottom. Then here for the 1/2, I'm going to need to multiply by 3 to get it up to a 6, which means I do the same thing to the top. This leaves me now with 4 over 6 plus 3 over 6. Notice that we haven't really changed these fractions. I could simplify these fractions back down to the ones that they were before. But now I have 4/6 plus 3/6 for a total of 7/6. Now that they're both sixths, they can be added together like apples and apples, as opposed to up here where I had thirds and halves, and it was like adding apples and oranges. Now that we've had a whirlwind review of fractions, we're going to come back to the main point of this chapter, rational expressions. Rational expressions are things that have a polynomial in the numerator and a polynomial in the denominator. For example, something like x squared minus x minus 6 all over x cubed plus 6x squared plus 8x would work. It's something with a polynomial at the top and a polynomial in the bottom. Similarly, I could have something like x cubed plus 2x squared plus x over x squared minus 1. That would be another example of a rational expression. You can even have something really simple, something like x plus 1 over x squared plus 2. All of the things that we can do with rational numbers, fractions, we can also do with rational expressions. We can simplify them, we can multiply them, we can divide them, we can add them, we can subtract them. Over this section and the next section, we'll be looking at how to do all of those things for rational expressions. In this section, though, we'll be looking at simplifying, multiplying, and dividing. Simplifying rational expressions is actually pretty easy. In a nutshell, we're going to factor and then cancel any common factors from top. In this first example, the factoring has already been done, so all we need to do is see if there are any common factors that can cancel between top and bottom. The top has an x plus 2 and a 2x minus 3. The bottom has a 4x plus 1 and also an x plus 2. That means that I can cancel out the x plus 2, since there's one on top and one on bottom, and then I'm left with 2x minus 3 on top and 4x plus 1 on the bottom. Now in this next example, it looks like we're going to have to factor things ourselves. Factoring is a skill that you should have done pretty solidly by now. So in these examples, I'm going to do the factoring pretty quickly. If you find that I'm going too fast with the factoring for you, that's okay. Pause the video, take a minute, and make sure that you understand how the factoring works. You can also go back and review more videos or talk to your teacher about factoring if you find that you're getting stuck on anything. Okay, with that said, let's go ahead and factor everything we can here and see if there are any common factors to cancel. So I noticed that this top factored as x minus 3 times x plus 2, and the bottom factors as x minus 4 times x plus 2. And aha, we've got a common factor here. The top has an x plus 2, the bottom also has an x plus 2. So I can cancel those out, leaving me with x minus 3 over x minus 4. In my third example here, I look at my numerator and see that I have only one term. So I'm not going to do anything to try to factor that just yet. On the bottom, I have two terms. I'm going to first see if I have a greatest common factor to factor out. It looks like 2 goes into both of these things, and they both have a z to the 4th. So I'm going to factor out 2z to the 4th, which leaves behind 5z squared, and don't forget that plus 1 to hold the place of the 2z to the 4th. Finally, I look and see if this thing that's left over could be factored any further. It has two terms, so the only thing I've got going for me might be a difference of squares, but it's not a difference, and 5 isn't a perfect square, so this is as far as the bottom. Now I look at my top and bottom and see if they have anything in common. I notice that both have a z to the 4th, so I can cancel that out. Between the 2 and the 4, I should be able to cancel a factor of 2 out. 4 is really 2 times 2, so if I cancel a 2 from the bottom, then the 4 becomes a 2, since that's all that's left over from the 4. That means that my final answer down here has a 2 on top, and just the 5z squared plus 1 left on the bottom. Notice that in all of these examples, we're doing exactly what you've done before when you simplified fractions. We're looking for factors that are the same on the top and the bottom, and then canceling them out. Next, I'm going to show you two examples that are a little bit sneaky. Here I have 5 plus x over x plus 5. It doesn't look immediately like these have anything in common, but if I rewrite the top as x plus 5 instead of 5 plus x, over x plus 5. Now I can see that the top and the bottom are actually exactly the same. Now when you take something and you divide it by itself, you always get 1 out as an answer. So there's my answer, 1. You can also think of canceling the x plus 5 and the x plus 5, leaving behind a placeholder 1 on top and bottom, which would leave us with the fraction 1 over 1, which is really just 1. For my second example, I have 5 minus x over x minus 5. Again, these don't exactly look like they have something in common, but they sure look so similar that we think that something ought to happen and go right here. For the 5 minus x, I'm going to try factoring out a negative 1. So if I factor a negative 1 out of the top, I have to switch the sign on the 5, make it negative 5, and also the sign on the x, make it plus x. That way, if I distributed the negative 1 back through, I would end up with what I started with. And on the bottom, I've still got this x minus 5. Finally, it looks like if I rearrange the top piece, it'll be the same as the bottom piece. I have negative 1 times x minus 5, which is the same as negative 5 plus x, all over x minus 5. Now I can see that when I cancel the x minus 5's, I'm going to end up with a negative 1. Now, I don't want to scare you too much with these sort of tricky examples. You'll find that this sort of problem doesn't really come up that often in practice, or even in your home. However, if you find yourself staring at a simplify problem, and the top and the bottom look similar but not quite the same, this is what you want to try to do. Rearrange one side so that maybe you see that the top and the bottom really are the same, and you'll end up with a 1, or try factoring a negative 1 out of either the top or the bottom, and then see if they have something in common that cancels to leave behind negative 1. Finally, I've got a couple rational expressions for you to try simplifying. Notice that on the first one, everything is already factored for you, so all you have to do is find any common factors and cancel. On the second one, though, you're going to have to do some factoring yourself. So go ahead and pause the video, try these, and then we'll look at them together when we come back. And we're back. On this first example, I decided to do the canceling step by step by step to show you each step, and also to show you that if you don't notice all the common factors right away, that's okay. You can still end up with the right answer in the end. So I looked at my top and my bottom to see if they had anything in common, and I noticed that they both had a 2x plus 1. So I canceled that out and then wrote down what I had. 2x squared times x minus 3, and 4x times x plus 3. Then I looked at this 2 and 4 and thought, I can probably cancel something from there. 2 goes into both 2 and 4. So I canceled the 2 from the top, and when I canceled a 2 from the 4, it left me with a 2 behind. So now I had x squared times x minus 3 over 2x times x plus 3. Finally, I noticed that I have x squared on top and a single x on the bottom, so I ought to be able to do some canceling there. To make that a little bit more clear, I went ahead and wrote out x squared as x times x, and then I've still got the x minus 3 on top, and then a 2 times x plus 3 on the bottom. Now it's even more clear that the x on top and bottom can cancel, leaving behind a single x on top, and x minus 3, and a 2 times x plus 3. Now again, I went ahead and did this problem in 3 different steps, but you really don't have to. You could get straight from here to here all in one go by noticing that 2x plus 1 on the top and bottom cancels. 2 goes into 2 one time, but into 4 two times, leaving me a ninja 1 up on top and a 2 on the bottom. If I have an x squared on top and a single x on the bottom, one of the x's will cancel from each, leaving me with a single x on top and no x's on the bottom. On this second example, we had to do some factoring. The top only had one term, so there wasn't anything to factor. On the bottom, we tried factoring out the greatest common factor, which was 3y cubed, leaving behind 2y minus 1. Again, don't forget that 1 for the placeholder. Then I could cancel the 3y cubed on top and the 3y cubes on the bottom, leaving behind a 2y minus 1 on the bottom. Now, if there's nothing left over on the top, there's always a placeholder 1 to make sure that you have a top and bottom to your fraction. At this point, I'm going to break this video into multiple parts. We've just covered simplifying rational expressions. In the next part, we'll cover multiplying and dividing rational expressions. So tune in when you're ready to multiply and divide rational expressions.